Alright, diagonal tree traversal. Given a binary tree, we return the sum of these diagonals. Okay, so basically, if you go right, you're staying on the same diagonal. If you go left, you're going to the next diagonal. So, so S, so these are my sums for my diagonals. Start out here, and then let's see, definite solve, and then root. Yeah, so we have solve here. So this is my sum, so my sum is equal to that so far. Yeah, which is also what I'm going to want to return. Return S, and then we want to switch down. We could do a DFS, sorry, so it doesn't really matter. Okay, or we could do a stack too. I guess if not, root return empty. So I'll use a stack, so I'll use BFS. Actually, if I do BFS, that's actually even better, isn't it? Well, it doesn't matter, because it doesn't matter what order I get them in. Okay, but we'll do this. So then I'll add a root, and we'll say this is the diagonals at the 0th index. Oops. Okay, and then do that, and then down here, we do while stack, and then do get the node and the index, which is going to be stack.pop. And then basically node, well, that's not true entirely, but let's think here. It's going to be, the node is in the right place, but something else that I'm missing. You need to add the value. So you need to take S, so I guess the IDX kind of tells you, I guess doing DFS search, I think, if IDX is greater than the length of S, then you should always do, I don't think it's ever going to get like a larger, so just do a pen, and then add the node.val. Okay. Else you would do S at IDX, plus we go to the node.val. Otherwise you want to keep searching. I want to go to the right first, so we'll say if node.right, then and 0. Well, it depends what IDX is. It's whatever IDX. It stays on the same index. I could do an elif. Dot left, stack dot append, node dot left, and then you always increment it by 1. but it says list index out of range. Okay. IDX is 0. Right, okay, I mean IDX is going to be 0, so I guess it plus 1 is greater than the length, which I think it is. So 1, okay, that's true. So then this should append no dot right, and it should append no dot left. So it'll pause the no dot left, and it will. Wait, I'm confused what's going on. So the 1, so it adds on. Let's also print out stack. Stack is empty. Wait, because you pop it off, and then you say if there's no dot right, you do. Oh, because I put an elif. Why did I put an elif? I don't know why. For some reason, I thought that was a good idea. Huh. So weird. Alright. Cool. So basically this works because, okay, so first I take it, it's not a root. So I start with a array that contains the sum along the diagonals, which we have no diagonals. Then we create a stack with the index of our first diagonal is 0. And then pop from the stack, pop the node and the index of the diagonal, and then increment the index, or if the index plus 1 is larger than the length, then you have to append it on. You have to add a new element in the array for the solution, and you start with the node dot value right there. Else you just increment it based on the node dot value, and then if you go right, you keep the same index. If you go left, you increment the index by 1.